Something is glowing beneath the far side of the moon. Not glowing the way a crater glows in sunlight, glowing in heat, in a place with no water, no plate tectonics, and no business producing the kind of rock that heat signature points to. When scientists finally traced the source, they found a buried structure roughly 50 kilometers across, sitting directly beneath one of the strangest patches of lunar ground ever mapped. And the material it's made of is something that, according to every textbook explanation for how it forms, should not exist on the moon at all. For over half a century, the far side of the moon was treated as the boring twin, cratered, quiet, and geologically settled. No human eye saw it directly until the Artemis II crew flew past it in 2026, decades after robotic probes had already mapped its surface in detail. What none of those earlier maps caught was what was sitting beneath that surface, radiating heat upward from a depth no camera could ever reach. 10 billion years is the kind of number space stories usually reach for. This one only needs 3.5 billion. And that's still old enough to make the discovery unsettling in its own right. The research comes from a team led by planetary scientist Matthew Siegler of Southern Methodist University and the Planetary Science Institute, published in 2023 in the journal Nature. The work was funded through NASA's Lunar Data Analysis Program and built on decades of measurements from NASA's Lunar Reconnaissance Orbiter, NASA's earlier Lunar Prospector mission, and microwave radiometer data from China's Chang'e-1 and Chang'e-2 orbiters. This is not a single instrument catching a fluke. It's a multinational, multi-decade data set converging on the same conclusion, reviewed and published in one of the most rigorously vetted journals in science. The site in question is called the Compton-Belkovich Volcanic Complex, tucked into the moon's far side, the hemisphere that never faces Earth. On the surface, it already stood out. Compton-Belkovich has an unusually bright, reflective patch of ground and elevated levels of thorium, a radioactive element that shouldn't be concentrated there in the amounts instruments were picking up. For years, that was treated as an interesting anomaly and not much more. Then Siegler's team applied a technique that had never been used this way before, measuring not just the surface, but the heat radiating up from underneath it. But naming the anomaly wasn't the same as explaining it, and what the team did next is the part that turned a curious hotspot into a genuine puzzle. To find out what was actually generating that heat, they had to stop looking at the moon's surface entirely and start listening to what was happening underneath it. That meant borrowing a technique built for something else entirely, and pointing it somewhere it had never really been used before. Think of it like this. If you press your palm flat against a wall, you can tell whether there's a heating pipe running behind it, even though you can't see the pipe itself, and the wall itself might not look any different to the naked eye. That's roughly what microwave radiometry does to a planetary surface. It doesn't photograph what's buried. It feels for warmth leaking upward through solid rock, layer by layer, and reconstructs what has to be sitting underneath to produce that pattern. When the team pointed that technique at Compton-Belkovich, the site wasn't just warm, it was glowing at microwave wavelengths in a way Siegler described as unmistakable, roughly 9 degrees warmer at depth than anything topography or surface material alone could explain. Here's the part that turns a warm patch of ground into something worth stopping the presses for. Heat like that, generated from below rather than absorbed from sunlight, almost always comes from the slow radioactive decay of specific elements buried in the rock. And when the team modeled what kind of rock could hold that much of those elements in that concentration, the answer that fit the data was granite, not a small pocket of it. A batholith, the geological term for an enormous underground body of solidified magma, roughly 50 kilometers wide, comparable in scale to major granite formations found underneath mountain ranges here on Earth. That should stop you for a second, because granite is not supposed to be a moon rock. On Earth, forming granite in any real quantity requires repeated melting and remelting of rock, a process that depends heavily on two things the moon has never had: abundant water acting as a chemical catalyst, and plate tectonics constantly recycling crust back into the mantle to be melted again. Apollo astronauts brought back hundreds of kilograms of lunar samples across 6 missions, and across all of it, researchers found only a handful of tiny granite grains, barely a scientific footnote. The formation, the size of the one sitting under Compton-Belkovich, simply had no precedent. As Siegler put it afterward, all the textbook ways of making granite involve processes that only happen on Earth. Quickly, before going further, here's where things stand 2 minutes in. NASA-funded researchers have confirmed a 50-kilometer body of granite buried beneath the moon's far side, detected through the heat its own radioactive decay is producing. Granite of this scale requires water and plate tectonics to form anywhere else we know of, and the moon has neither, which means either something rewrote the rules for how this rock forms, or the moon was hiding a far stranger geological history than anyone accounted for. Both possibilities are still on the table, and neither one is comfortable. Now here's the part that connects this to the bigger picture of how the moon actually grew up. Granite bodies like this don't appear in isolation. On Earth, a batholith this size typically sits underneath and feeds an entire chain of volcanoes, the way the Sierra Nevada mountain range is itself the exposed remains of an ancient batholith that once powered a volcanic system running down the western United States. Siegler drew the same comparison directly, pointing to the modern Cascade volcanoes as an example of what a magma system this large usually builds on the surface above it. If Compton-Belkovich worked the same way, it means the Moon once ran a volcanic plumbing system on a scale nobody had documented there before, evolved, layered, and active for a very long stretch of lunar history. That gap between what the surface showed and what was actually sitting underneath it is, in a strange way, the whole story here. So what actually built it, if water and plate tectonics were never in the picture? That's the question the research team is still working through, and to their credit, they haven't pretended to have a tidy answer. One possibility involves a large mantle plume, a rising column of unusually hot material from deep inside the Moon, feeding magma upward over an extended period and letting it remelt and refine itself into something granite-like through pure persistence rather than water. Another possibility is, stranger still, an unexpectedly wet pocket hidden somewhere inside the Moon's interior, isolated from the dry surface geology everywhere else, quietly enabling exactly the kind of chemistry that shouldn't be possible there. A third option involves an unusual concentration of heat-generating elements alone, radioactive enough to keep remelting the same material over and over without any water involved at all. Researchers from Stony Brook University, who contributed complementary surface analysis to the broader investigation, noted that whichever explanation holds up, the scale of what's been found implies an evolved Earth-like granite system larger than anyone believed possible on the Moon. If you're a few minutes into this and thinking that sounds almost too tidy for a rock, scientists can't fully explain, you're not wrong to be skeptical. And that instinct is exactly the kind this discovery earns. This wasn't announced through a press release and left there. It went through peer review at one of the most demanding journals in science, and it was independently discussed and cross-checked at the 2023 Goldschmidt Conference in Lyon, France, in front of the international geochemistry community. Planetary geochemist Stephen Alardo of University of Florida, who wasn't part of the original research team, called the find-in incredibly interesting precisely because making granite without water and plate tectonics is, in his words, quite hard. Outside validation like that matters. It's the difference between a claim and a result that survived scrutiny from people whose job is to find the holes in it. There's also a question worth sitting with about why this sat undetected for so long in the first place. Compton-Belkovich isn't hidden in some inaccessible corner of the Moon. It's been photographed by orbiters for years, and its surface anomalies, the unusual brightness, the elevated thorium, were already on record decades ago. What kept the granite invisible wasn't distance, it was depth, and the fact that nobody had pointed the right kind of instrument at it in the right way. Topography, surface color, and standard photography all missed it completely, because none of those methods can see past the top layer of dust and rock. It took heat, radiating up from tens of kilometers below the surface, measured patiently across years of overlapping orbital passes from two entirely different national space programs, to finally reveal what had been sitting there for roughly 3.5 billion years, waiting on data nobody had thought to combine this way before. That combination is worth pausing on because it's part of why this discovery holds up. Chang'e 1 and Chang'e 2 were never designed with this specific question in mind, and neither was the Lunar Reconnaissance Orbiter when it first launched in 2009. Siegler's team pulled years of archived measurements from missions flown by two different countries, run by two different space agencies, for two different original purposes, and layered them together until a single, consistent thermal signature emerged. That kind of cross-mission agreement is exactly what makes a result hard to dismiss as noise or instrument error. To be clear about what this discovery does and doesn't prove, because the honest version of this story is more interesting than an exaggerated one anyway, nobody involved is claiming the Moon secretly had oceans or plate tectonics like Earth's. The data shows a large radioactive granite formation exists, and it shows that formation is generating measurable heat today. What remains genuinely unresolved is the mechanism, whether a mantle plume, a hidden pocket of water, or a self-sustaining radioactive feedback loop built it, and the researchers themselves have said as much. This is population-level evidence about the geology of one very well-documented region, not a claim about the Moon's interior as a whole, and treating it as anything more than that would go beyond what the data actually shows. What makes this land so hard isn't just the size of the formation. It's the fact that a world we've been photographing, mapping, and in some sense walking on for over half a century still had something this large hiding in plain sight. 3.5 billion years old, waiting for the right instrument pointed the right way at the right moment. Every generation of lunar mission before this one had the same information available and simply lacked the tool to read it. The far side of the Moon has always been the half we can't see from home. Now it turns out it was also hiding a piece of its own history that shouldn't have been possible to write in the first place, sitting quietly beneath the surface the entire time, radiating just enough warmth to eventually give itself away. Tell me in the comments which part actually got you, the idea that granite this size exists on the moon at all, or the fact that it sat there undetected for over 50 years of lunar exploration before anyone thought to check for heat instead of just looking.